Evening, everybody. Better preface this talk by saying that I know nothing about clockmaking, or I didn't until I started making these clocks, and now I know a little bit, but not very much. So it's all make it up as you go along, really. So start off with why make a clock? I've always been fascinated with clocks, especially big clocks. That's a massive clock. It's taller than I am. I know that's not very tall, but it's bigger than I am. And it's just incredible to think a blacksmith made that. I mean, it's 1699. It's a bit later. There are plenty of earlier ones. But if you look at the work in it, it's incredible. Because it's all the welds are fire welds. It's all been fire welded together. And they made these lantern pinions where you've got 4 or 5 pieces of round bar, all welded to 2 pivots, all in a fire. How they ever did it, I don't know. So it's just amazing. There's a smaller one. That's a bit more local. That came from Castlebury Park in Watford originally. It's now in the British Museum, where it's actually working, so it's quite nice to see it working. Yeah. So I just like these mechanical, they're almost like mechanical sculptures when you watch them working. So great. Right, let's move along. So obviously I'm not going to make a tower clock like that because I haven't got a forge to make it in. But I quite like these lantern clocks. They're reasonable size, manageable, big enough so you can see what you're working on. So I don't know how anybody makes a watch. It's just unbelievable. So I settled on that. Just a little bit of the history. I'm not going to give you a long talk about the history because I don't know that much about it. So the pendulum came in, or was invented about 1650, came in from Holland, and the first pendulum clocks were produced in about 1650. Prior to that, there was some other clocks made with different type of escapement. That's the thing that controlled how fast it unwinds itself, using a balance wheel or a thing called a virgin foliot, which is 2-way, both of which were incredibly inaccurate. Not that lantern clocks are a great deal more accurate, but they're slightly better. The interesting parallel is that clock was made by a guy called Thomas Tompion. He's a very well-known clockmaker. And at exactly the same time, he was making these clocks. I did have the privilege of seeing one of those in pieces on a bench being overhauled. And the workmanship inside is absolutely incredible. Everything is polished. There's not a scratch. There's not a mark. And it's incredibly complicated inside. So I got into trouble once with a clock expert for referring to these as the Timex of clockmaking at the time. He got a bit upset about that. He said you should call it an Amiga of... But it's essentially an almost mass-produced clock, rather than one that could only be afforded by royalty or nobility or something. So a reasonably well-off merchant or, I don't know, bank manager or somebody like that could probably afford one of these. And I think at the time people like Tompion they wouldn't be making them one-off. They'd probably make a batch of 10 or something and then sell them. Mass producing obviously speeds the whole process up a lot. So that's history-wise, that's just important to see the two things are running in parallel, but aimed at 2 completely different markets. Okay, just have a look at the workings of it. It's about as simple as you could make a clock, really. It's you have a rope with a weight on it that wraps around this spike drum here. The hands are driven from here, straight off this main arbor. This actual section is for one with hours and minutes hand. The one I built here has only got an hour hand, as the earlier ones had. So it's the rest of it. Whoops. Get the right button. The rest of it, all of this, the green bit, the purple bit, and all the yellow bit, and all this, is just to control how fast the rope unwinds itself. If you take that away, it just crashed to the floor and whiz round. So it's gradually releasing that in a timed way. Where are we? So the chassis of the clock, if you like, is a brass plate at the bottom, 4 pillars, one on each corner, and then a plate on top. The movement is held on 3 cruciform plates. There's one there, one in the middle, my head doesn't shake too much, and one this side. Okay. The 3 cruciform plates are just pinned to the bottom. They're not a tight fit, they're lift off. They're not loose, but they're not tight fit either. But the top of them is just in a tenon at the top, so that the plates are free to move to a certain extent, which I couldn't quite get my head around when I first started doing it. It didn't seem logical. First one I made some spacers that I bolted it all together with, but that's how they were made. So the whole thing is quite flexible, and we're not talking about precision engineering here really. It's quite inaccurate, a lot of it. And apparently a clock movement, of this sort of clock movement, if it doesn't rattle when you shake it, it's never going to run. So everything's quite free floating, fully floating, as they say. Okay, so that's the chassis of it. I say it's not like any of the later clocks where everything is clamped together, much more precise. Okay, gears in clocks, they refer to them as wheels if they've got 13 or more teeth, and pinions if they've got 12 or less teeth. Tooth form for clocks is a cycloidal form, which is not the same as the involute form that we're used to in most other things. I assume cycloidal was the easiest one to produce at the time, because you have to bear in mind that a lot of the early clocks, these guys, will be making them with no machine tools. A lot of this would be filed out using a template, the teeth. So, I mean, there's still people that can do that today. I don't know if anybody watches YouTube. There's a guy called Clickspring in Australia. I watched him filing out gear wheels by hand. I don't know, it's just incredible. I can never do that. So it's easier to produce, I think, and it's easier to make the cutters for, which I'll come on to in a minute, because it's less.
I think involute produces constant pressure and constant speed.
Yes, probably.
I don't believe cycloidal does.
These just drive each other around somehow or other.
I'm not sure that matters too much in a clock.
No. Well, not in a clock like this anyway, no.
There's also less friction, which is important.
Yeah. Okay, just see the tooth profile. On the wheel, the flanks are straight, and then there's the cycloidal curve at the tip of the tooth. Okay. The pinion, the smaller one, slightly different kettle of fish in that the flanks are slightly angled as well, which makes them even more difficult to cut. Theoretically, if you want to do it properly, every combination of the number of teeth and which the number of teeth on the pinion and teeth on the wheel requires a different angle and different radius for the tip. So if you're going to go to the nth degree, you've got hundreds of gear cutters to make them, although you can double up. I think especially important with the pinions, the little ones, because they are hard to get a decent shape out of. When I started off this project, I got hold of a copy of this book, which I just happened on by chance. He's an American guy, and he goes through a whole process of making the cutters using his method. which I did try to make some, and I've cut some wheels using them, but it's very hard to get the surface finish on the cutter good enough that you don't end up with a ploughed field across the tooth of each one. And I'm not sure the angles are that accurate anyway, so that's interesting book. Okay, so there's a picture. So on the right is a Thornton's cutter. Thornton's about the only cutter manufacturers in the UK, I think, and that's a one-man band. But they're problem is they're quite pricey. You're looking at about 90 quid a piece for them by the time you've got one, and you might need 10 or 12 to make a clock, so it starts to get a bit expensive for that. So I used a few of the homemade ones for the ones, especially if you're cutting in brass, it's not too bad, you can get away with it. Cutting steel, it gets a bit harder, it's not so easy with your own ones. I did cut some pinions with them and just made them out of silver steel using his method to get the radius at the tip and the angles. And then just harden them. I left them all dead hard, I didn't try and temper them. And I never broke one, so it is possible. But as you can see on that one, I think the surface finish on the flanks of the teeth is hard. It's very hard to get them glass smooth like the professional ones. Okay, so look at cutting of the wheels now. So this is how I cut the wheels. You can see the trusty Thomas dividing head in action. The wheel blank is super glued to a chunk of aluminium, something like that. So I put them in the lathe, true up the face of the aluminium, slap the wheel blank against it, centre it with the tailstock so it's roughly in the middle, and then turn up the OD, bore the centre so it's all running true. And then you can transfer it over to the mill. I try various methods, but I end up with this. I've got a spindle for the dividing head. Everybody can see that. It's a spindle with a flange on it with some holes in it. And that bolts onto the aluminium. Okay. The bolts are a sloppy fit in the plate. So when you get it up in the mill, just clock it back square, just tap it till it runs true again. Thornton cutter in the mill. The other device here is my 12-pound Chinese 1000 zoom microscope, which is pretty useless because you can't figure out what you're looking at really. But, no, it just needs turning down a bit, but it looks like everything you look at looks like a ploughed field with it. So I cut them on this. It's a BCA jig borer, which works pretty well for making clock wheels, but it's not a milling machine. It's what it says it is, a jig borer. It had a good reputation, I think. Mine's a bit knackered. One of the gibs in the X-axis is broken, so but it's good enough. It does. Keeps me happy anyway. So, just run through the process, then cut the blank out of some sheet, put the aluminium block into the lathe, face it up so it's parallel, super glue the blank to the aluminium, skim the OD to get it round, and then I drill the centre hole, and then I bore it just to make sure it's true, or near as I can get it anyway. Swap it over onto the dividing head, blew up the outside diameter of the wheel, then I cut the teeth almost to depth in one pass, especially with brass, you can just whip through them, okay, through. And then I just take a second pass so that you can just see a very faint trace of blue on the tip of the teeth. Now, every book you look at and you read tells you something different about the depth. Every table you look at's got a different depth. So I spoke to a couple of people and they said, well, I just cut them down till I can just see the blue on the tip of the tooth. And so that's what I did. Oh, there's the other bits on for the dividing head. I've got a adapter that'll take a Myford chuck. That's one I use with the aluminium blocks, and the one that's in it at the minute, which is a ER clock collet.
You're cutting aluminium as well?
Yeah, you chunk.
Yes, you can't.
Cut chunks out
So
of
you
it.
need a separate piece for each gear? Well, unless you start off with a big gear and cut down
What?
machine something else.
No, I mean, I've got a couple or three pieces, and I just chew a bit out of it to get it out of the way of the wheel every time. Yeah, eventually they have to be thrown away and start again. But, originally, I did cut a few with it just super glued on, and then one day it fell off. So after that, I started putting a little bolt through the middle of it just to make sure it didn't fall off. But surprising how well super glue does hold it, as long as you get it clean, obviously. So, in the past, I think clockmakers used to use shellac. They used to use a block of wood, turn out a hole in it, or the depression in it, fill it with shellac, and then slap the wheel blank onto it.
How did you separate the super glue, John?
Bit of heat. Yeah, just warm it up till it pops off. Yeah.
Because there's a sort of method somewhere soaking it or something that soaks up.
Oh, I don't know. No, I just.
I wonder if you use
Yeah, no, nothing secret. Just a bit of heat and off it.
survive above 200 degrees. So.
Yes, it doesn't have to be that hot. So yeah. Okay. So we've made the wheels. Next process is what's called crossing out. That's cutting out these holes here. It's hard holding this still, isn't it? I've got shaky hands. The crossing out process is cut the holes out with a piercing saw and then file them to shape. To get them to look nice, you can do it any way you want, but the way I've been doing it is with a jig like this, which has got various holes in it, depending on how many spokes you want and how big the wheel is. And then you have a large peg on one side of it, small peg on the other side, and then run the rule across it, and you can scribe your lines onto it, and then you go around.
Do they have to be perfectly balanced?
Preferably, yes. Again, for a lantern clock, it probably doesn't make much difference, but if you are making a decent regulator clock or you were going a chronometer, yeah, I'm sure they would have to be. I did cheat because I found I can file up the centres and the spokes okay by hand, but trying to get the outside radius round so it looks round, I found it impossible. You always get a bump in it somewhere. So now I cheat. I run them round on the milling machine first and then file out the corners. One thing I hate to see is when you've got a radius in that corner, it just looks like they've been made on a milling machine. So I normally I file those out, and sometimes it looks all right and sometimes it doesn't look quite so all right. But it's a lot easier than trying to file that radius by hand. Okay, so that's the wheels. Right, probably the hardest job is cutting the pinions. They're it's not perhaps the best, is it? A better picture. So you've got a piece of silver steel in the dividing head, you've got your cutter in it. So you're only going to cut 6 teeth around the outside of that. And the hardest bit of the whole thing is getting the cutter at the centre of the pinion, because the slightest, and I mean slightest deviation, when we get the camera going, I'll show you some examples of what happened. I've tried various methods for centering it, but what I normally do now is use height gauge set to the height of the centre line of the dividing head, then add on half of the cutter thickness and measure off the top face of the cutter. And it's better than most things, but I still often have to throw away a 2 or 3 before I'm happy with it. It's incredible. And you can't tell if you've done one tooth, you can't really tell by looking. You've got to take it out of the machine and look at it, and it just doesn't.
Can you do a length of pinion and then just cut pieces off that you want?
You could, yes. Yeah, and that's commercially how a lot of them are made, I think. In these type of clocks, though, the pinions are cut directly into the arbors themselves. So it's all one piece, so you've got to cut it. But the professional clockmakers, yeah, they'll cut a length of it and then drill it through and put it onto the arbor. And originally, I think you could buy stuff called pinion wire, which was a length of pinion and sort of stick like this. And I think it used to be drawn originally. I'm talking 100 years ago now, not recently. And I even heard stories of if a clockmaker only had 7 teeth pinion wire, they'd cut one out and hammer the rest of them round till they got to 6. So I mean, we're not talking precision engineering and a lot of this stuff. So it's, but anyway, it's just another shot of what a good backup support for it, because it's fairly hard. Yeah, that's what happens when you don't get it right. Get some horrible looking things. Another scrap one. I've got a whole bucket full of them at home. So. Okay, what have we got? Okay, the next part of the, see, I'm not sure, did I put, yes, is what's called the contrate wheel. That's this right angle drive here, which looks like that in theory. So you turn up the blank, cut the teeth in it, and then because to me the geometry then doing that is all wrong. You're cutting straight lines through a round body, which can't work really. But the way that it was done on these clocks anyway, they used to thin the inside of the teeth from the inside till the outside edge was almost a sharp point. That one's not very pointed at the minute, to try and get over this problem with them binding up. It's still the biggest problem for why my clocks won't run anyway. It uses an awful lot. You lose an awful lot of power in there because of the incorrect geometry. And the other thing, that looks a bit off, a bit skewed.
When you say you thin it down, is that way?
Yeah, you cut from the inside, so the tip of the tooth is thin,
It's really thin.
and it gets thicker towards the. Just helps. The other thing I started doing with them, because still fighting with the friction, obviously, you've got the pinion that's resting down here. I've got it sitting on a little ball bearing in there. So I just harden the end of the pinion and set it on a ball bearing. And I think I've seen some people say you should put a ball bearing on both sides. But depending on how good the fit of your pinion is in the bracket, I was just wondering about 2 ball bearings running around each other.
Yeah.
So I thought I'd go with a flat end on one and a ball bearing on the other. That looks a bit odd, that one, doesn't it? It looks a bit off-centre, doesn't it? Just put a little dimple in the end of the screw there and a little dab of Loctite. Hold it all together. Like lots of things. Okay, the other thing I've never understood how you're supposed to do it properly is how you get the depth of engagement of these 2 wheels. According to the drawing, you just turn up the flange, sit it on there, rivet it on, and then I can't see how you get any adjustment on it. So unless, your work's incredibly accurate, it's never going to work. So I resorted to making a longer boss on here so I could move the pinion slightly on its arbor. That got me fairly close. And then I'm still having trouble. I make some little brass shim washers, so I can push this wheel from side to side very slightly. Because it's not easy to get them to mesh properly. They're either you're too far out and they're not driving properly. You get too close, they butt up against the end. One tooth butts up against the end of the next tooth. So there is supposed to be a tool for setting it up, but I've never figured out how to use it or what it's for. So it's a tricky thing to make. Yeah, that's just to show you where this contrate wheel sits in the train. There's one with it, got this extended boss on it. So it's just a light press fit in there, just so if you need to, you can move it slightly if you want to, backwards and forwards.
Is that turned from the solid?
Yeah, that's one of the problems now. Everything's turned from solid, and I'll come on to that in a minute because it gets expensive. Okay, this usually shocks most engineers when you're talking about meshing a gear train. So in clocks, done using a depthing tool. So you make your gears, you set them up in a device like this, and you adjust the distance between them till you like the way it runs, till it sounds nice. It doesn't grate and block up. And then when you're happy with that, you use these 2 points at the end here to scribe 2 lines on the plates, and that's where you drill your holes. And most of the time you cross your fingers and hope it works, but sometimes it doesn't. My first version of this, I'm getting so many problems with it. Depthing wasn't right all the time. And I looked at it, and then I did a bit of measurements, and I suddenly found out that the distance between these two wasn't the same as these two. So they were pointing, and I think what had happened when I was making them, I did all this work first, and then I cut these slots out, cut the chunks out of it. And I think this aluminium plate must have moved around as I took the piece out of it. So I chopped the ends off it and made these tidier bits on it. That's a bit of fiddling and filing, and they're reasonably pointing in the same direction now. I don't know if anybody's seen the commercial ones, but they're real works of art. Beautiful brass things. Cost hundreds of pounds now. Yeah. So it does its job. Next. Oh, right, let's see if this works. Good, here we go. Right, so here, you've got the contrate wheel that we've been talking about here, driving the pinion underneath it, which drives the crown wheel up the top here. We'll come on to that in a minute. Okay, here's a better view of the top half of it. So what we've got here is a crown wheel, which is on the vertical pinion that we've been looking at. It's got a support here to hold it up, and then the verge staff runs across here, and then hanging down the back here is the pendulum. At the front there is just a plain pivot, okay. But at the back here it sits on a knife edge under here. I'll show you that in a sec. So it's all, to modernise it all looks very crude, and it was really. It's, these guys were making these things virtually in mud huts with no electric light and all hand tools. Right, this verge staff. So in the drawings that I had, it was a model engineer article written like 1970 something. Galia says, take a piece of 3/8 silver steel, turn it down to an 1/8 diameter over most of its length, leaving 2 lumps here that you're going to file to shape, and then file up this bit as well. So I thought, the chance of me getting that right, 0. Absolutely 0. Thought of trying to turn a piece of 3/8 silver steel, nearly 6 inches long, down to an 1/8. Not going to happen, is it?
No.
So, well, not in my competence anyway. So I redesigned that. Well, I made it in 3 pieces. So the staff itself, a little lump here with the knife edge on it, and the pendulum rod here. Quite handy because it allows, because this is a fit in here, little grub screw, so I can adjust that, which is a big help. Pendulum rod screwed in there, and okay. The 2 flags, I milled 2 slots at 90 degrees to each other, half the distance through, two pieces of gauge plate on there, file them to shape. And if I didn't like it, I unsoldered it and did another one. One of the good things about making clocks is you can afford to, most of the bits you can afford to chuck in the bin if you're not happy with them, apart from the plates.
Is that soft solder?
Yeah, I soft soldered it all together. Yeah. Oh, it's just milling the flats onto the verge staff there. So, at least I can guarantee that they're 90 degrees to each other, and just easier to fabricate something than. I have seen other books that tell you to take a piece of flat, saw out the bits you don't want, leaving the 2 flags, and then heat it up and twist it 90 degrees. So how that's going to stay in a straight line, I'm not quite sure, but I don't know. Must be some cleverer people than me around. Oh, that's the knife edge. So the back of the clock, where the pendulum is, it sits on that little knife edge there, and then there's a groove that it sits in and a piece of brass. So it's
It sits in a groove.
It sits in a V, so the edge of the knife is sitting at the bottom of the V. Okay. But the V is a lot wider than the knife edge, so the pendulum can swing from side to side.
And there's virtually
What about the radius in the bottom of the groove? Is it?
Yes.
Is the radius controlled? Or?
No. Well, only as. I mean, it's not dead sharp. So it's just, again, to try and reduce the friction as much as possible. And yeah, I agree, it's not an engineering solution, but it's how it was made.
Comparison to the knife edge on the balance.
Yeah.
Yeah.
So that's, oh, sorry about the quality of the picture there. That's the crown wheel. I don't know why I put the picture in there, really. It's not. Again, it's turned from the solid, crossed out. Oh, there it is in real life. And again, that's what I want to show you. Yeah, this is the exciting bit, cutting out the teeth on the crown wheel. So this is the latest improved method, with the bolt to hold it on, and the big lump of steel resting against it to make sure it doesn't fly off. So it's just a fly cutter that's shaped to cut the teeth, chews its way out, and got a bit of filing to do to tidy it up afterwards. I did have one of those come off as well, which is not really surprising if you're not bolted on. Okay, well, we're getting nearly to the end, and we're doing time. Oh, all right. Okay, these finials, these are the fancy bits at the top. A bit of a nightmare to make, really, I thought they were. First of all, I have to bear in mind, none of these dimensions are critical. As long as you make all 5 the same, it doesn't really matter within reason what they look like. It's just to give you an idea. Originally, these finials, the columns, the feet, and various other bits would have been cast. The clockmakers would have been buying these in from a brass founder who specialised in making clock stuff. So, unfortunately, nobody does that sort of stuff now. So they all have to be turned from solid, which is a bit wasteful anyway, to say the least. And I had a lot of trouble with these because doing this bit was fine. You could get out to about here, normally all right. But when you try and turn these two, there's a big bang, and it breaks off there. So, another picture, yeah. So I ended up making it in actually 4 pieces. So I made the body from here to here in one piece. That piece is a separate piece. The 2 little balls at the end is another piece. And then to save material, instead of turning this out of the brass, I drilled and tapped them inside and put a bit of threaded rod in it. Because it just gets so expensive now. You're turning away half the material you're buying all the time. It's crazy. So that works well enough. They just make these so that they press together. And if it's a bit dodgy, you put a bit of Loctite in it. Make sure it stays there. What else have we got? Okay. So there's 2 of them solid. And these need pressing together a bit more yet. And even then, some of them don't look exactly the same, the bits. The most boring part about the whole thing is polishing everything. You spend hours and hours polishing it.
Do you lacquer them after you finish polishing,
No.
to preserve them?
No. So I don't think it looks right if they're bright and shiny. You need to let it oxidise naturally, really. And once you've got it. No, and certainly any original lantern clock wouldn't have been lacquered. They'd have been just allowed to tarnish us.
You had servants to polish them, didn't you? So you had servants to polish them.
Yeah, but I don't think they even did that. So I wouldn't think. Nice for now. Now, it's one thing I've learnt is to polish the parts as I make them, not make them all, and then polish them later, because it doesn't half get boring polishing all this stuff. So they don't look too, well, they look all right if you don't look too carefully. Those are pre-polishing those. Oh, there's some rather crude form tools I used to make some of them with. Just bits of gauge plate. Right, the pillars were another expensive bit to make. So they're just shy of 6 inches long, and they started off at 3/4 round. So they were done in the lathe, obviously, by offsetting the tailstock. Yeah. Not ideal, but I haven't got a taper turning attachment, so that's what you do. And you've got to be really careful they don't come loose, because as it's not running square with the centres, it tends to wear the hole in the end. You tend to get some wear in there.
I think you can get a tool that sits in the tailstock to off-centre.
Yes, yeah.
Or the boring end.
Yes, yeah.
Hemingway, I think.
Yes, I think, I think you're right, yeah.
You can also use the different, if you're using a centre drill, you've got some centre drills, so instead of having 60 degree, you've got a curve.
Oh, right.
They were designed for use on grinders, where you're offsetting down.
Oh, right. Oh, that would be, yeah. Anyway, I did finally get my tailstop back on centre again, but
That's why you use it.
took several,
That's why you use a book.
yeah, several failed attempts. But it is quite a wasteful process, this.
Yeah.
There's a lot
Did you
of,
not have made them up out of 3 bits as well?
well, funny you should say that. Just out of interest, the 3/4 diameter brass works out at £27 something a foot now, whereas 1/2 inch diameter is about half that price. No, third of the price. So what I did in the end was to make them in 3 parts. So I made the main pillar, and then I turned up these top bits, which are the bigger diameter, separately. And they sit on a little shoulder on top of the pillar there. And nobody's any the wiser. But it's a huge difference, huge jump in price in material. So let's save a bit of money on that. Okay, we're nearly at the end. Yeah, right. Okay, these things called frets. And their only purpose is to fill up the gap between the bell and the top plate and hide the escapement and the hammer and all the rest of it. And originally, these would have been castings as well. Tied it up with a file and then sent out to the engraver to be engraved with the pretty pictures. And this classic design with the 2 sea creatures, dolphins or whatever they're supposed to be, you see on a lot of lantern clocks. But the design of the frets is a whole subject in itself with lantern clocks. People can date a lantern clock fairly accurately by the design of the frets. If you're having it made for you, you probably get your coat of arms put into it as well or something like that. But if you're buying one off the shelf from a clockmaker, then you have to put up with whatever he gives you. Okay. So at the moment, I've just got a piece of brass that I've hacked at with a piercing saw, file it roughly to shape just to fill in. I don't suppose I shall ever find any fret one, not that I can afford anyway.
In the example you've got on the right, is that an alarm in the middle?
Yes, I think this mine might be. It's just one I picked at random. You're right. Yes, it is. It's just a picture I picked at random, but yes, you're right. Yeah. What else do I need to get? Yeah, the other problem is the bells. The bells. Okay, so you probably noticed this is a plastic bell. I have found one bell. Not quite the right shape, but it is a bell. Lantern clock bells, you find a lot of long place clock bells, grandfather clock bells. They're all over the place. But there's very few lantern clock bells because they're slightly deeper. They go down at the sides a bit to look right. So I just put those in there for the minute to make it.
Castings, or
Yeah, they would have been originally, yeah.
have you tried raising one out of a sheet?
Well, I was wondering, but I wonder if a metal spinner could spin.
I was going to say, spin, yeah.
Cause I think if a steel spinning would probably ring to some extent anyway.
Make it out of brass,
Oh, right, yeah. Now, so I might investigate that in the future.
Going to be here spinning done.
Yeah.
Probably charge.
Yeah. In the model engineer article, I had to laugh. It said, make yourself a pattern for the bell, take it to your local brass founders, who will happily cast you one.
That's 1975, mate.
Yes, that's right. Yes, right.
50 years ago.
Yeah. Now, there is a Bell Founders Tailors up in Loughborough still. And I did talk to them briefly, and they were talking about £200 a piece for, yeah. So,
But they make about a bell.
yeah, proper bell metal, yeah,
Copper.
yeah, yeah. I think, oh right, yeah. Just to close off then, why you should always check everything twice, if not 3 times. So when I made the second and third ones, I ordered some brass sheet for the cruciform plates from a different supplier, and instead of applying 1/8, which is what I ordered, it was 3mm.
Yeah.
So I jigged it all up to get the right distance between them and square and all the rest of it. Then to turn it all upside down and drill through from the bottom to put these pins in it. But of course, because this was 3mm and not 1/8, and I'd worked it all out for 1/8, the back 2 came out halfway through the upright. So, yeah, had to fix that. So, oops, never mind. So it just goes to prove never trust anybody with anything.
Or check.
Or check multiple times. And that's it. Here's the 3 of them. Still a bit
You made 3.
finishing off.
3 of them.
Yes, yeah, I mean,
Well done.
yeah, one for each kid was the idea.
Does one know he's got a plastic bell?
No, I'm going to put them 3 in 3 cardboard boxes and pick one. No, they've got a bit more to do yet, but see, originally this area here would have been engraved to look nice. You'd have had some engraving up here. This would have been nicely engraved. And I did try making the dials. I tried to photo etch the dials, but that was I couldn't get the film to stick to the brass properly every time, because some of the finer detail, every time you touched it, it fell off. So I gave up, and I've got a friend who does commercial engraving for trophies and stuff, so he knocked me up these 3. They don't look right. I mean,
Does the bell actually strike? Does it actually sound?
yeah, it could do, yes, yeah.
Does it? Could it? I think does it?
Does it? Yeah, sometimes. Sometimes.
You said that you've got to wait. So this is going to sit up on.
Yeah, it's got. I have to have it up about here somewhere to make it run for 24 hours. So.
Well, I mean, it's in its own sort of.
No, you just have just a wooden angled shelf. It sits on the wall, and the weight just hangs down in. Yeah.
Did you ring on the hour?
Yes. Yeah.
Just a passing strike.
Yes. Yeah. Just.
One of our club members years ago, he was a club member when he was a teenager, after he graduated in music, for a while he was working at the Bell Founders in London.
Or Whitechapel. Yeah.
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 I'm not sure what's happened to him now.
Oh right. Right. Yeah. Yeah, because obviously Whitechapel's vanished now, so it's a hotel now. So. Yeah, so I could do a bit more work to them yet.
Did it strike a number of hours?
Yes, yeah,
Yep.
yeah. And it's once you've got your head into it, it's quite easy to see how it works. But the first couple of times it takes a bit of working out. It's they're not very reliable. If the wind's in the wrong direction, or it's an hour in a month, they won't run. If you take it, I've taken this one to pieces to clean it recently, and it won't run at all at the minute, so I haven't got it running here for you tonight. Once you've got them running, they're okay, but they don't like being moved, touched, cleaned, disassembled, or anything such.
Would it normally be put in a glass case or something to keep the
No.
dust out?
No. The only thing they would have had was some doors on the side to keep the dust out. But that spoils the fun of it for me, because I want to see the bits going round inside.
I think you can buy glass domes.
Yes, yeah. But they, no, traditionally they wouldn't. They'd just been sitting there.
Do you have a
Yep,
sundial to set it to?
Yeah. Run out to the church clock, yeah.
Well, is that would have been done originally?
Yes, yeah. So I think a lantern clock, they probably say it keeps time to within sort of 5 minutes a day.
That would be considered way more than
Yeah,
necessary at the time.
yes, no, it's good enough. Because I think some of the other ones, the balance wheel clocks and the others, were sort of 15, 20 minutes a day if you were lucky.
You lubricate it?
I just put a tiny trace of oil on it as I put it together, yeah. So it's,
That's also one of the big problems, isn't it?
yeah, put too much oil in it and too much oil, yeah, not enough oil.
Oil becomes thick.
Yeah. So there we go, that's about,
Did you want to show some close-ups on
oh, I got to, there's some bits, or people can come around and have a look, whichever they want to do. Do you want to put the camera on for a minute? Yeah. Are we okay for time at the minute? Yeah. When I first started on this project, I didn't have a dividing head. So I had a Unimat lathe at the time. So I took the headstock off of that, sat it on a block of aluminium, and then made some adapters so I could fit the Myford change gears on the back of the spindle. That worked all right for some, but then of course you come to tooth count that you can't get to. So the clockmaking had to stop, and I cobbled this together from a Hemingway kit. It's not very nicely finished, as you can see, but the object was to make a dividing head, was to make a clock, not a dividing head. But, sometime I'd spend a bit of time on it. So I made an ER11 collet chuck for it, which is good for cutting the pinions and stuff like that. I haven't got it here. I've got an adapter so I can fit the Myford chuck. I've got a 4-jaw self-centering Myford chuck that I use on it. And then the other plate that I showed you before, so that does the job. Seems to be reasonably accurate anyway. When you go around the wheel a second time and nothing gets cut out, you say a small prayer and carry on.
Centre the wheel on the axis well enough, because I do it in the lathe and then cut the gear in the lathe, because I can't get it centred.
Oh, right. Yeah, not too bad, yeah. I mean, I'll spend a bit of time clocking it up when I put it into the mill, but to get it good. So there, okay. Okay, what else have we got? The depthing tool. Yeah. So this is the Mark II. We've got a better location of the axles. Fiddled about with those for a bit with a file to get them to point in the same direction, because that's I think it does teach you how to bush the pivots when they don't line up. So if you look carefully, you'll see there's a couple of bushes in them. So with the pivots in the brass plates, the normal practice with clockmakers when they get worn, you drill a bigger hole, put a piece of brass in it, and then re-drill the pivot hole. So rebushing operation. So sometimes if it doesn't work out right, you have to do that and carry on. Does its job. What else have we got here? Right, I don't know if we can get this or not.
Yeah,
hang on. I need to find the one I want to show you first thing. Right, that's as I said, getting the pinion cutter exactly on the height is a bit of a nightmare, really. And I mean, that's an exceptionally bad one, but you just the slightest adjustment makes a hell of a difference with it.
Do you mind just parking your finger next to it so we can see the scale?
Yeah, what have I got like sticking there? You see my big pudgy finger there?
Yes, I see.
Yeah. So using the height gauge and, you know, the centre height plus half the cutter gets you fairly close. Although I did read somewhere somebody complaining they got some Chinese cutters and the profile wasn't cut in the middle of the blank. So that's the other thing. Okay, I think that's about all I need to show you, really. So we'll take a break
The
there.
clock isn't running. It would be nice to see the movement.
No, didn't like being transported. No.
No, the escapement's not moving, is it?
No, it's not happy at the minute. Problem is probably either the depthing of the contrate wheel or the adjustment of the pallets on the crown wheel. Yeah, or the height of the crown wheel against the pallets. Because every time you read a clockmaking book, I get a different answer for how long the pallet should be and how far apart they should be, and everybody seems to have their own method.
The actual parts on this, what sort of lifetime would you expect if it ran continuously? Obviously you need to stop it to maintain it and clean it off, but I mean, would you need to replace these parts every 20 years or every...
No, I think they've run a lot longer than that. I'm sure there's, you know, some original lantern clocks still running. They may have been rebushed at some stage. But, yeah. Yeah. A lot of lantern clocks, though, were pendulum lantern clocks in the Victorian era were re-engineered, if you like. They changed the escapements, they put them onto chain drives and all kinds of things. And certainly a lot of the balance wheel clocks, the older ones, were converted either to pendulum or to an anchor escapement or something, because they were so inaccurate that it was, you know, just a joke, really.
What's the period on the pendulum? Is it 2 hertz?
Or? It was theoretically a half second.
Yeah.
So yeah.
Yeah. Full swing.
Yeah, yeah. But it's all a bit academic, that really.
No lantern purely from the shape.
Yeah, the lantern is that it looked like a lantern, really. That's where it came from. So the brass lantern clock, like this one, is pretty unique to Britain. They don't exist anywhere else in the world. Prior to this, there were a lot of continental Gothic clocks, which had 4 pillars, one on each corner, often made of steel rather than brass. But the brass one with the 3 cruciform plates that hold the movement up seems to be fairly unique to Britain for some reason. So
when does it receive the impulse to keep the pendulum swinging? Is that as it? I understand the escapement's got 2 sort of flags.
yes, yeah.
One is responsible for impulse, or are they both doing both?
No, they're both doing the impulse.
And the impulse.
Yes, so it's the overswing of the pendulum.
Okay.
So it's
So it will unlatch from one.
yes,
The tension will kick the other one.
yeah, because the movement is actually going backwards
Yeah.
at a point every time, which is, well, one of the reasons for crossing out the wheels, to take the mass out of the wheels, so there's less inertia all the time. But I'm not imagining it's going to make much difference.
Is that the only sort of real sliding point on the RMF? Or
Yeah, the flag's on there, yeah.
and
Obviously.
they last for hundreds of years?
Yes, I wouldn't say hundreds of years, but they'd last, you know, somebody's lifetime probably, yeah.
How long have you been making these things?
How long? I started when did I start in? 2019. But I've moved house twice, built 2 workshops, made a dividing head and a few other things in the meantime. So.
Are you self-taught?
Yeah.
When you retire, will someone give you a clock?
No. We've got one in the family, one of these, but an original one.
Right.
So they're different. So I've always thought they were quite nice looking things. And it's,
You said that there's no covers on these.
No.
When you think of the houses they were in, or they were in, there was a heck of a lot of dust and
Oh, they must have been filthy. Yeah, yeah,
They must
yeah.
have been clean, had to be clean.
yeah. And there seem to be magnets for dust.
Yeah.
I don't know if it's just the oil or whether it's, I don't know. Yeah, yeah.
Would the coal be abrasive or soot or?
It is in oil.
It is.
Yes, yeah.
Must be the grinding.
Yeah.
Yeah, but you get it cleaned every year, probably by one of the apprentices of the clockmaker who made it for you.
Yes, yeah, something like that. So it's
When I was working 40 years ago near Stanmore, one of the other employees had been a clockmaker, and when he was an apprentice, he was sent round the big houses in the area
yeah,
to wind
the clocks, yeah,
because they would not trust the servants to touch the
clocks, yeah, yeah, I believe it, yeah. The other nightmare is when you've polished it all and you're trying to put it together. So I've been using white cotton gloves, but have you ever tried assembling anything in white and cotton gloves? It's,
Try, if you can get hold of them, try aircraft pilots' silk gloves.
right. Yeah, they'd be finer, wouldn't they? Yeah, yeah,
More difficult, yes.
yeah, yeah. No, you spend ages polishing it and then you touch it once and, you know.
So how do you get that on your wrist? What's the next step?
Oh, yeah.
Very big
What?
strap.
The mini version. Yeah. 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 Okay, here we go. I think I'm about done. Any more questions? No?
Thank you very much, Andrew.